In this video, I'm going to go over the next set of slides, which are the slides about Java primitives. This corresponds with concepts and ideas that come out of Chapter 2 of the textbook. And then following that, in the next video, we'll actually dive into some detail with some samples from Chapter 2. So we're going to talk about Java primitives, the primitives of the Java programming language. These are the smallest elements, if you will, of the language, and from there we will build up to bigger things. So here's a few terms to understand. First is the idea of a data type, and I'm specifically talking about a primitive data type. You probably have some idea about what data types are from your programming class prior to this. And if it was Python, you recognize that there were numeric data types, and these can be integers or they can be floating point values. There's string data types, there's date data types, there's all kinds of different data types. But what there wasn't in Python was anything called a primitive data type. When I talk about primitive, I talk about data types that are either numbers or Booleans or characters, but are not objects in the sense of object orientation. In Python, there's no such thing. Every single piece of data that you have is going to be an object, an instance of a class. But in earlier languages, there was such a thing, and there is such a thing, and Java has a few of them, and we'll be looking at those. So what is a data type? It's basically a description of how the computer, or a specification of how a computer is going to treat some bits found in memory. Remember, everything that a computer deals with is bits. What is a bit? A bit is an on-off switch. It's either a 1 or a 0. And we talked about bytes being 8 of these bits and things of that nature. So I might come across some bits in memory, and depending on whether I wanted to treat it as an integer or as a floating point value or as a character from, an alphabetic character, I would be treating these bits differently. The very same pattern of bits would be treated differently, and that's determined by the data type. So that's one thing to consider. Now, there's such a thing as variables. Of course, we had these in Python as well. A variable is a named location in memory. It's going to have a particular data type, a specific data type. In other words, once that variable has been created, you cannot put into that variable anything else that is not consistent with that data type. And again, this wasn't exactly the same in Python. In Python, you never declared a variable. We'll talk about that. Here's this word declaration here. We never declared a variable in Python. We just used a variable. We assigned a value into something. We'd put the name of something on the left-hand side of an equal sign of an assignment operator, and we'd assign a value. And then from that, the decision was made, okay, there must be a variable. And based on the value that was assigned, there was a decision that was kind of done behind the scenes, under the hood, that was deciding, okay, that must mean this is that data type. But that's not the way it works in Java. In Java, you have to explicitly declare variables to be of a particular type. Now, notice that the term variable implies that it can vary. The contents can change, as we see in this blurb here. And there's something else called a constant, also a named location in memory. But in this case, the value can't change. And there was no such thing as a constant in Python, although you can treat variables as if you want them to be constants. But there's really no such thing in Python. And again, we come to this notion of declaration. You never declared variables in Python, but you declared functions. So declaration is kind of the definition of the thing, and in Java, we'll have to actually declare our variables. Now, there's another possibility for a piece of data is it's just something you've hard-coded into your source code, like the number 10, 1, 0. If I said x equal 10, well, the 10 is a literal piece of data. Or if I had something in quotes, maybe that would be a string, and that would also be a literal piece of data. It's part of the statement. It's not based on a variable. It's not based on a constant. It is actually a literal piece of data. Now, with variables and with constants and with literals and other kinds of data, you can combine them in various ways using different kinds of operators. There's arithmetic operators, addition, subtraction, multiplication, division, etc. There is comparison, or sometimes called relational operators, greater than, less than, equal to, not equal to, all those kinds of things. You should be familiar with all of those things from your previous programming experience. And the combination of any literals or constants or variables along with the appropriate operators is what's called an expression. An expression is anything that ultimately gives you a piece of data. Operators, variables, constants, literals, and maybe even method calls. And the methods return a value, and that would be also a piece of data. That would be considered an expression. So anytime we are using an assignment, and here's that term assignment here, and I'm sure you must be familiar with that from Python, from CIS 221. Anytime we are doing an assignment, what you have on the left-hand side of the assignment operator is the name of a variable, and what you have on the right-hand side of the assignment operator is an expression. And that expression could just be a literal, it could be a variable, it could be a constant, it could be some kind of combination of these along with operators. But whatever it is something that's going to give you a piece of data. And then what does the assignment do? The assignment takes that piece of data once it's been evaluated and puts it into the location of memory that the variable name is referring to. And then finally, the notion of a statement. This is an instruction. It says this is a program instruction telling the CPU what to do. I think probably a more accurate statement would be it's an instruction telling the Java virtual machine what to do, and then the Java virtual machine is actually might be breaking that instruction into a bunch of smaller instructions in order to really tell what the CPU is going to do. And as we saw already, all statements in Java end with a semicolon. So I talked about primitive data types. So there's such a thing as primitive data. When I use that term, what it means is that the variable will actually contain data itself. And that's not what was happening in Python. In Python, the variable did not contain data. Instead, the variable contained a reference to data that was located somewhere else in memory. In Java, there are many variables will be references. Probably most of the variables will be references. But some variables will actually have values, data values in them. And these are the different data types: Boolean, char, byte, short, int, long, float, and double. Notice that they're lowercase b, lowercase c, lowercase b. There's actually corresponding classes in Java: uppercase Boolean, uppercase char, uppercase byte. But that's not what we're talking about here. We're talking about primitive data types. And we already know that Booleans are true and false values. A char is a single character. And you'll notice that it says it's a Unicode character. When we talk about Unicode, there's a discrepancy between Unicode and ASCII, A-S-C-I-I. ASCII is 8 bits for a character, but Unicode is 16. Well, 8 bits for a character is enough for representing all of the letters of the English alphabet, both uppercase and lowercase, and then all the digits and all the punctuation marks, and enough left over for some other special little characters if you want. But it's not enough for dealing with all of the alphabets of all of the languages on Earth. 16 bits is plenty for that. 8 bits can represent up to 2 to the 8th power combinations of patterns of bits, and that's 256 different possible patterns of bits. So 256 different possible characters could be represented in 8 bits. But 16 bits, that's over 35,000. And once you get to that point, you've got plenty enough for all of the alphabets. So one of the things that Java and Unicode brought, and Java was an early adopter of that in languages, was to basically make it easier for software to represent international characters. And then there's 4 different integer primitive data types: byte, short, int, and long. And they're varying sizes, as you can see. 8 bits, well, you're not gonna be able to represent a very big number. Basically, you can represent, if it was a signed integer, one of those bits have to be the sign, and then the other 7 bits are gonna be the values. And basically what that means is you can go from negative 127 to positive 128 or something like that. So that's not going to give you much. 2 to the 7th power, it doesn't give you all that much. 16 bits is better. Again, you're going to be many tens of thousands. 32 bits is usually what we're going to need to use. 32 bits is going to get us into large enough numbers for our purposes. But if you really needed really large numbers, you can have 64 bits. So those are our integer data types. And then there's the idea of floating point values, which means something that you would have something to the right of the decimal place being able to be represented. You can't do that with a byte short int or long, but you can do it with a float and you can do it with a double. And in those cases, part of these 64 or 32 bits is for what's called the mantissa, and the other part is for what's called the exponent. And so that's how we're able to get places to the right of the decimal place being represented here. And that's it. Those are the 8 primitive data types. Any other variable of any other type is really going to be a reference to an object on what's called the heap. And you'll notice there's no such thing as string here as a primitive data type. String is a class. It is not a primitive data type. Just to illustrate that, here I am in the Oracle documentation. And here we have a class called string. So obviously string has data in it. You can see, you can assign a string value into this variable. But also it has a whole bunch of behaviors that you can do with it, a whole bunch of methods that you can call. And you were able to do a very similar thing with Python strings. So you're going to see the same sort of thing happening with Java strings as well. But again, string is not a primitive data type. It is a class. And most of the data that you're going to work with are going to be classes, but some of them are going to be these primitive data types. And variables, constants, methods, classes, all of these things have names, and oftentimes this is termed an identifier, and every programming language has some set of rules for using identifiers. So here are the rules with Java. It has to start with either a letter, an underscore, or a dollar sign. Can't contain any of the operators or any of the reserved words. Can't be any of the reserved words, I should say. So I can't have a variable called if, lowercase I, lowercase f. Can't be true, false, or null, and there's really no limit to what the length of a variable can be. Later, we'll talk about some of the conventions used for naming variables. In the Java world, people tend to use what's called the camel case naming convention, and we'll get into that a little bit later. But at any rate, variables, constants, classes, methods all have to be named, and sometimes we use the word identifier to refer to that. So here's some declarations of variables. And as I said, in Python, you didn't do anything like that. So notice what we're saying here. We are giving a data type, and then we're giving the name of the variable, and it's a statement, so it's going to end in a semicolon. So here we made a variable called x, and it's going to be an integer. Here we made a variable called radius, it's going to be a double. Here we made a variable called char, called a, and it's going to be a char, which means a single character. A single character. So there's a distinction here between a string and a char, and they're treated differently, and we'll see that. Here's the general format, and as you can see, if I wanted to have multiple of them, I could declare multiple of them, all of the same data type. Notice also that in Java, and we'll see this, unlike in Python, you can actually wrap your statements around, because how do we know when you're at the end of the statement? We know it because there's a semicolon at the end. With Python, there's nothing at the end. But with Java, there is something at the end. So if you have a long statement, you can wrap it around. There's a way of putting a continuation character in Python to be able to wrap around as well. But you don't even need a continuation character with Java. So here's some example assignment statements now. So we've declared variables. The previous slide was about declaring variables. And this slide is actually about assigning values into variables. And as I said, always, always, always on the right-hand side of the assignment operator, which is the equal symbol, just like in Python, to be distinguished from the comparison operator, equal, equal, again, just like in Python. For an assignment operator, always, always, always to the right-hand side of the assignment operator is going to be an expression, and in this case, the expressions were just literals. And to the left-hand side of the operator is going to be the variable, the name of the variable, the identifier of the variable. Notice that with a char here, in this case right here, with the char, when I said a equals and then in quotes a, that uppercase a is a literal value, but this is a character value. This is not a string value. literal character types of values in Java are not treated exactly the same as in Python. In Python, it doesn't make any difference whether you use double quotes or whether you use single quotes. Either way will work. It'll be the same thing. It'll be a string. But in Java, if you use a single quote, it's a char. It can only have one character in there. And if you use double quotes, it's a string. It can have as many characters as you want in there, including just one if you want, or for that matter, you could have an empty string if you want to. So there's another little distinction, syntactical distinction between Java and Python. And of course, you can declare and initialize in one step. So here we have a declaration taking place, and then we have the assignment taking place. And we're seeing that with a number of different, again, literals on the right-hand side of the assignment operator. One note here that you'll see this F here. By default, a floating point literal is considered to be a double. And if I wanted to explicitly state that, no, this is supposed to be a float, I can put an F there on the end. I doubt that we're ever going to really run into that. In fact, I doubt we're going to really use floats. We're probably going to just use, as far as numeric variables, we're probably just going to stick with ints and doubles. But, just to let you know, there's all these different options. And then how do we make something into a constant? We make it into a constant by preceding the data type with the word final. And final is an example of a modifier in the Java language. As soon as you say final for something that would otherwise have been a variable, that makes it into a constant. And you'll notice that there's a convention here that the names of constants are uppercase. You don't have to do it that way, but that's kind of a convention in the Java community. And we'll talk more about those conventions later, not in this video, but in the next video. By the way, when you declare a constant, you have to give it a value. You have to assign a value into it. And then from there on out, you cannot assign any other value into it. And here are a bunch of other numeric literals. And their options. And now we can come to the kind of operators. And these operators are going to be very similar to what you had already seen in Python. At least the arithmetic operators are, and the assignment operator is, and the comparison operators are. The logical operators are different. Of course, in Python, you had the word and the word or and the word not. So you're going to have to get used to these differences syntactically, 2 ampersands, 2 vertical bars, the exclamation point, things of that nature. And so this combination of the variables and constants and whatnot and literals with the different kinds of arithmetic operations, or I should say any kinds of operations, are going to form the expressions. So there's the arithmetic expressions, there's conditional expressions, sometimes called relational expressions, and arithmetic expressions are working with numeric data and giving you a number back, and conditional expressions are working with Boolean values and logical operators. And those can be based on comparisons as well. And these return a Boolean value. So here's some arithmetic expressions. None of this should be new to you. Here's a couple of statements that have arithmetic expressions. So assuming the radius had been declared as a double or a float or something, and the same with area, they must have been declared prior to it because you don't see the declarations here. We've assigned a value into radius, and then we've used that variable in an expression in order to come up with the area. And then we assigned another value into radius and did the same thing. So again, these are variables. Radius and area are variables that can be changed from time to time. Always, 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 as I said before, to the right-hand side of the assignment operator is an expression that's going to give you a piece of data. What that means is that this expression right here that's giving you that piece of data, that full expression has to be evaluated first before the assignment can take place. In terms of the order of operations that are taking place here, first you got the multiplications taking place, giving us the result, and then only after that is when that result is assigned into the variable. And here we have a bit more complex of an arithmetic expression. We'll be seeing some other examples of more complex arithmetic expressions as time goes on. Maybe you were working with something of this complexity when you were doing stuff in your earlier programming class. And Java, like other languages, has shortcuts that you can do. These augmented assignment operators are an example of that. You have the same thing in Python. Plus equal is basically if you have a variable and you want to take the contents of that variable, you want to manipulate it in some way, and then you want to assign that result back into the variable, which is really two different things, right? You've got the arithmetic operation and you have the assignment, or you can combine it something like this. So I plus equals 8 is the same as saying I equals I plus 8. And the same thing for multiplication or whatever. One operator I didn't tell you about is the modulus operator. Sometimes, and it's the remainder operator. That was this one. Where is it? Right here. The remainder, or modulo, modulus. That's basically if you take two integer values and you divide one by the other, and there's something remaining, that's what that's going to give you back. And you can do the same sort of thing with the augmented assignment operators for that. You had the same thing in Python, as I said. This shouldn't be new to you, the ability to use this kind of shortcut. But one thing you didn't have in Python were these increment and decrement operators. And they operate kind of interestingly. The increment operator is plus plus. If you put the plus plus after the x, or before the x, in either case, you're going to wind up adding 1 to x. In both cases, the net result on x would be the same as saying x equal x plus 1 or x plus equal 1, and the same thing with the minus. However, putting it before or after makes a difference in terms of when it's being used. For example, in this case, x is incremented after adding it to the 2. So the result that would be in y, in this case, would be 2 plus 1, and then x would increment to 2. On the other hand, if you put the plus plus before, first x is going to be incremented, so x is going to change to 2 first, and then 2 plus 2 will give you 4 in the y. And here is a slide that kind of shows that as well. So what do we have here? We declared a variable, gave it the number 10, and then 10 times 10 would give you 100, and then we would have added 1 to 10 and it would have given us an 11, as opposed to doing it before in this case. So little subtle differences based on when you do the increment or decrement. It's important to know when you're doing division, whether you're working with integers or floating point types of data. When you are doing a division with integer types of data, it's always going to truncate the result. So, of course, 1 divided by 2 is 0.5, as we know, but really what we're going to get is a 0. 1 divided by 2 would give us a 0. 1 modulus 2 would have given us a 1. 0 with a remainder of 1. When we're dealing with floating point division, it's going to give you a double result. And if it turns out that you're dividing an integer by a floating point number or vice versa, what you're going to wind up with as a result is going to be the floating point number. And in general, when we're performing operations that involve two operands, and in this case, what are the operands? Here's an operand, the number 1, and here's another operand, the number 2. Here's an operand, the number 1.0, and another operand, the number 2. So the operator is working on these two operands. And if those operands are of different types, then Java is going to automatically convert the result, the operand of the smaller range to the data type of the larger range, and that's why we're going to wind up with a floating point value instead of an integer as a result of an operation that's like this. So this is a bit different from Python, at least Python 3 and above. In Python, you had two different kinds of division operators, one specifically for integers and one sometimes called a floor division, and another one for floating point values. And that will give you floating point. So if we did 1/2 in Python, we would get 0.5. We would have to do 1/2 in order to get the 0 in Python. So here's our char data types. Again, note that the literal has to be in single quotes. Java code uses, as you see, Unicode representation. So this \u, the backslash is an escape character. We'll talk more about that. But taking all of that is going to give us some special character that might not be visible on your keyboard or something like that. And so this is the char data type. I doubt we're going to use chars all that much in class, maybe a little bit. And speaking of escape characters, here are some important escape characters. You, I think, did something of this nature as well with Python. Probably the two that are going to be the most important for you is the tab and the line feed. You might also, if you really wanted to embed into your string a backslash or a single quote or a double quote, you might use an escape character for that. But for the most part, you're going to want to go to the next line or tab over, and those are going to be the escape characters you'll use mostly in your strings. And here's some Boolean. So the word true and the word false are basically literal values. We're assigning that into a variable, a Boolean variable. Here we have a couple of comparison expressions. 1 equal 1, of course, is going to give you a true, right? 1 equal 2 is, of course, going to give you a false. So you can have on the right-hand side of an assignment into a Boolean variable any expression that gives you a Boolean result. And here, similar to as in Python, you have some concatenation that you can be doing. What's happening here is that we're concatenating these values together. Notice that the variable area and the variable radius, I mean, assume that those were doubles, but as soon as we started to do concatenation, we took a string and we started concatenating numeric values with that string. We started using the plus symbol in the context of a string. What the Java virtual machine does is automatically convert the content in area into a string and convert the content in radius into a string in order to perform the concatenation. You did concatenation, I'm sure, in your previous class as well. Some Boolean operators, and I think I have some slides with some truth tables here. None of this should be new to you, so I'm just going to kind of go through them. If I see anything that looks of interest, I'll talk about it. Here's our ands. Okay, in order for the and to be true, and P1 and P2, those were Boolean values. Both of them would have to be true in order for the final result to be true. For an or, if only one of them is true, then the result is going to be true. You should know all this already. This is called an exclusive or. You might not have run into this before. And an exclusive or means that one of the values is going to be true and the other value has to be false. So if they're both true, the exclusive or is going to give you a false. If they're both false, the exclusive or is going to give you a false. But if one of them is false and the other is true, or vice versa, the exclusive or is going to give you a true. This has to do with numeric type conversions. So let's look at this. Consider these statements. And when we perform a binary operation involving two operands of different types, we're automatically going to convert based on this rule. If one of the operands is a double, the other is converted to a double. If one of them is a float, it's converted to a float. If one of them is a long, it's converted to a long. Otherwise, both are going to be converted into integers. In other words, whatever the combination of these two operands are, we're going to convert the one of the smaller size into a bigger size before doing the operation. There may be times when we want to treat something as if it's of a different data type, and this is called typecasting. And sometimes it happens behind the scenes without us even worrying about it. If I wanted to assign this value 3 into the variable called d, which was a double, in this statement right here, well, the 3 was an integer, but there's automatically a conversion that's done in that expression so that it will become a double. So that resulting double is going to contain a 3.0, not just a 3. If you wanted to go the other way, if you wanted to go from a double or a floating point value into an integer, then you have to explicitly typecast. And that's what's taking place here. When we convert the 3.0 into an integer, as we're doing here with this typecasting, we wind up with just a 3. For that matter, if we convert a 3.9 into an integer, we also wind up with just a 3. In other words, the fractional part is chopped completely off. This is not rounding to the nearest integer. This is truncating. And then finally, for this set of slides, just to give you an idea of the operator precedence, you should be aware of this concept of operator precedence. Some things take place before others. You already have known it for a long, long time with arithmetic. You know that multiplication and division takes place before addition and subtraction, unless it's overridden by parentheses. So all of these things can be overridden by parentheses if you want to. So here's the precedence. Actually, this is stuff that's discussed in Chapter 3, not in Chapter 2, but I thought I'd put it in these set of slides here. The precedence is first the increments and the decrements, then the typecasting, then not operator, then your multiplication, division, modulus, then your addition and subtraction, then your comparisons. So if you've got comparing two different arithmetic expressions, the arithmetic expressions are going to evaluate first before the comparisons take place. And in your comparisons, you've got your greater than and less than and things like that coming before the equal and not equal, oddly enough. Then your exclusive or, then your and logical operator, and then your or operator. So you got to be careful with that because the same was true in Python, by the way. And will take place before or. So if you got a bunch of ands and ors mixed up, and you want to make sure that your or is taking place before your and, you're going to have to wrap parentheses in order to override those precedents. And finally, after all of that is said and done, that whole expression that might have had all of these different operations taking place, finally the assignment can take place, and that would be the last thing. So that's what I had to say about some of the concepts from Chapter 2. And the next video will go through some examples from Chapter